also everyone. So what it is, and soon, like I'll also describe that who am I? Am I eligible even to teach you or tell you something about it? So yeah, I mean the subject is applied AI. There is a lot of buzz about AI. Everywhere AI is around, and I'll just brief about myself. So I have in total of now 16 plus years of experience, out of which 16 years of algorithms and softwares experience, out of which 9 plus or 10, around 10 years of dedicated experience with building products for AI companies. Now, many of the people in this room know me since 10, 15 years. So, yeah. And those who are new here, so basically, yes, I have experiences of building products for some good companies. I have been earlier founding member of a company, of a startup earlier back in 2019, which I left in 2024. It was a pure AI company. We raised up to $8 million dollars and everything. And then I left in 2025 January. And then basically what I have been doing, I have been basically using the same principles of AI. Basically, I have been uh, you know, working on a new theme of AI basically. And recently, although I did not made a lot of noise on social media itself, but yeah, I mean, I had recently started my services of providing AI based basically forecasting services for financial markets, specifically for crypto. And I have one paying customer. So recently that was started, and few of the people have joined me from the previous batch. I mean, this is my second batch, wherein I thought that I want to brush up this whole knowledge, because AI is a tricky knowledge. So I will like to brush up my knowledge when I teach all of you. I read extensively all of those old books and new books again, and on top of that I bring new content every time. I mean, it's not that the same, it's not, the idea is not that I'll be bringing the same content in each of the batch and everything, and I will be holding maybe 2 or 3 batches in a year. So this is the whole idea. My This is not my bread and butter. I mean, so I work full time on something different, on something other research thing, which is very wonderful, and sometime going ahead I can talk about it. So this was just a brief about me. And as we discuss about the problems, I can even discuss more about things. What are these things, right? Now, yeah, obviously this is applied AI. A lot of things, when I read on LinkedIn, I'm not a marketing guy, so I don't post that much on LinkedIn. And plus, you not being a marketing guy, basically you cannot post lot of false stuff on LinkedIn. So basically, what we are going to discover, there's lots and lots of people talking about AI is this, AI is that, and people even raising funds on AI and doing whatnot. But what we have to understand, that what AI actually is, what is this whole fuzz about, what AI can do, what it cannot do, that is very important to understand, right? The perception has been built like AI is some magic pill that just landed in 2020, and then after that, it kind of changed the world. It did change the world. Chat GPT did bring a lot of things, but AI was long before. AI is has been coined 75 years ago. AI is not a new term. Neural networks, all of the technology that we use, they're all old. Obviously there have been like new research, new additions, every 5 years, 10 years something new cracks in, and then we build upon that. But yes, I mean, the AI itself is old. It is not, there is nothing new. Obviously with chat GPT and all, the problem was, for training that kind of model you require a lot of money. So chat GPT and all of those companies, they gathered that money, they had that kind of money, so they were able to train that GPU and all of that, right? But what we are here to understand that, how all of this thing is actually working. We will be understanding the very utmost basics of everything. The idea is that we understand the whole basic structure, that what is the basic structure. uh, Starting the whole idea here is we will be building these AIs, exactly. We'll be building these chat GPT things and all from the scratch. I'll be doing it before you, right? The idea is not that I'm not using any pre-built things and then I'm showing it to you, right? The second thing is that what comes into the mind that, oh, it is going to be a very tough job, definitely it is not easy, but it is not as tough as it seems to be, right? When the information is presented to you in the structured format, when you get the information in the structured format, obviously things become easy for you. However, when the information is very much in the haphazard format, in the unorganized format, it becomes difficult for you. So this is the whole idea that you learn this, all of the practical things you learn, all of everything you learn, all of the things I'll be building before you. It is nothing I'll be taking from anywhere and then I'll be coming and running here, and no, no, nothing like that. I mean, some of the guys from previous batch are also here, so obviously uh, they know that that is not a lie. So basically we'll be building everything from zero, from the single line, right? So I am also an author of a book called, LLM, basically building LLMs using PyTorch. And we are actually on the same subject, but we are on applied AI. Soon I will talk that what does applied AI means, and, what does what is the difference between traditional AI and what we are going to focus upon. So we'll be focusing on a specific thing, but from the foundation itself, right? Now, the okay, very common question is, do we require maths? Yes, you do require maths, but you have been using maths in your daily life till date, right? You might say that you require calculus, but yes, again, I would say you were using calculus in everyday life. So maths is not something that you were not using. The only problem is that with all of us, including me, I was also a victim that maths was taught to us in such a way that we felt that it is so difficult. Actually, we are natural mathematicians. It's just we had not discovered that thing yet. So yes, we require maths, but it is not that complex mathematics. It is a simple mathematics that you use in your daily life. And when I say really, it is just, I mean, someone looking at the cricket screen, when you are actually looking at that score, obviously you are looking at linear regression screen, right? You're looking at some graphs, you looking at some stock chart, you looking at some Bitcoin charts, you looking at some indicators or anything. So you are already using those kind of maths. You're already using differentiation basically, and you might not be even noticing that, right? Do we require lots of coding? We will require basic scripting, but not lots of coding is required. See, artificial intelligence or all of these things, these are algorithmic subjects. These are basically brain subjects. What does it mean? You can actually write your whole logic in Excel cells, right? In the Excel sheet, you can actually write down your whole logic, right? So scripting is just a way how do we need to make it understand to the systems, right? So like I said, I mean, it is most of the thing is all about logic here, right? There are so many concepts to cover before starting AI. We need to learn all of it now. Basically, before I even started all of this batch, in previous batch, I was also thinking that how should I start, you know should I first explain all of the huge concepts? There are lots and lots of concepts involved, you know but the approach that we will be taking is problem to solution, top down approach, instead of learning first. So what we have been doing most of the times, especially with the Indian education system, that we have been learning a lot of theory, lot of mathematics, lot of physics, and lot of that economics and all of those things. And then by the time we come to the market, either we forget it or we are not able to apply it except a few. However, the thing is that first we'll hold on a problem. We'll first identify a problem. We'll do our research, right? We'll do our learning on it, and then we'll develop it, test, and solution. So this way, when we identify the problem and we solve it, so basically we will be covering the required concepts as and when required, rather than we first discussing the whole theory that this is what we need to do, this is what how it is done. So basically, yes, uh, problem to solution. So basically first we will identify the problems, we'll identify the use cases, case studies, and everything, and then we'll keep on solving them. Then we will keep on learning that, okay, to solve this problem, this is what we require, right? So just like you, many of you might be solving many problems which you have not studied about, right? When you go to a doctor, basically you research about the medications that are given to you, or whatever the report is generated. So you are not a doctor, you're not trained for that, but now basically everyone can go. Now it has become easy, but even before chat gpt, people used to go on internet. They used to do their due diligence, and they used to come back, right? So this is the whole idea, this is the whole idea of learning. This is how humans learn, basically the natural way of learning. And creation is fundamental nature of humans. If you see, always creation, whenever you create something, it gives you a dopamine rush, it gives you a happiness. And this is what we humans are basically when we create anything. So we'll be doing all of that, right? uh, Enough of talking, but yeah, I mean, just 1 to 2 slides before I jump to the main thing. What, who this course is for? So basically, like I said, I have an like entrepreneurial or struggler mindset. It is for software engineers who want to be an AI engineers. It is for entrepreneurs, basically, who want to have their own startups and everything. Future entrepreneurs, existing entrepreneurs, future entrepreneurs. It can be students who are aspiring for their career in AI, or any problem solver. Now, again, like I said, uh, I am not very much, promoting the whole idea. I mean, I'm not doing it for some just that you enroll to my course or something. The whole idea being that I am against the idea that if you have this specific education, then only you can do that. I mean, that is a bad idea, basically. That limits your creativity, that limits your ability. So the whole idea is at any point of time you can learn anything. But yes, I mean, the learning has to come to the right channel, and it can be self-learning or whatever you wish to do. Right. And yes, the whole idea again is that, I again and again encourage everyone around me that I have that right experience, at least in Indian startup ecosystem. What kind of ideas get funded, what kind of ideas um, you know get evolved, how to test your go to market strategy, how to search for your idea. I might hold one small session, maybe I'll post it on YouTube, that basically how even I have been doing researching on ideas, and how I theoretically thought that this could be an idea, when everyone rejected the idea, saying that this is not even possible. So how I scribbled on the paper, and then I started working on all of those things. So basically, I encourage all of you to be future entrepreneurs. Now, basically, entrepreneurs, you need a brilliant idea. Yeah, obviously, for if you want to sell your services, obviously that's a different ball game altogether. But yes, I mean, if you want to have your idea, wherein you want to convert it into some good product, some innovation that no one, or someone should really face some huge amount of time to conquer whatever you have built. If someone is able to conquer whatever you have built in less amount of time, then obviously you will be facing a lot of struggle into the market, right? Okay. About Instructor, I have already told a bit about me, and then as and when we go, basically, we'll continue to know each other, basically. And the next step is magic is in the AI. Oh, I guess I made a mistake here. Magic is in the AI. It should be I. Basically, this is a problem, I guess, in the slide. But no, there's not a problem in the slide. This is the reality check. The magic is not in the AI. Magic is in something else, right? So let's discover where the magic actually lies, and where uh, uh, a lot of reports and everything you might be hearing that people first, in when if you see the curve of all of this AI, back in 2023, how it started. In 22 to 23, it was like AI is going to take away this, AI is going to take away that. And mind it, this is not happening first time. Although I will go back, I'll cover 10 minutes of history maybe tomorrow. The same kind of uh, revolution or marketing gimmick had happened in 1960 for AI, right? And the idea was to raise funds to sell people something. So basically, the maximum advantage that in this whole 5 to 7 years, who have gained is basically the cloud companies. They have gained a lot, right? If you see their earnings, they have just shot up, right? So magic is in the AI, and then what started happening? People have started doing is, people, what they thought is that, AI is everything, Chat GPT is everything. So what common mistake they do is, they collect anything and they dump it onto Chat GPT or whatever your favorite LLM is, Grok or anything, Gemini, whatever it is. Right? They collect all the data and they put it in the LLM, and they think that this AI is some kind of magical pill that is going to crack everything. No, it is not the case, and hence people, what they are doing is, they will just take their Chat GPT API and they will connect it to their product, and thinking that this is going to solve the problem. Obviously, when LLM is not trained for doing that, how is it going to solve the problem? So we'll have to understand what this LLM is, and if this problem is not going to be solved by LLM, that then how can we either make LLM make this problem solve, or how can we build an AI that can solve this kind of problem, right? Now, basically, if we see this image, wonderful image, uh, what nature is having wonderful pictures, trees and mountains and rivers and everything, right? Now, but if you see this, what a common human might see that, just give me a second, guys. Right. So what basically, what you're trying to see is, this beautiful scenery. You'll see a peaceful landscape, but what uh, we should be seeing, or what wannabe data scientists should be seeing, you know, this is a massive amount of complex hidden data. This is some massive hidden data that is present here. There are a lot of patterns that are present here. Every tree, every mountain, every river is following some rule. You know, in nature, this is how nature is built. And when I said that the magic is not in the AI, the magic was already present in the data. The magic was already present in the data, but our human brains are really small. So without using any tool, it is really hard to see that pattern, right? So rules of nature, there are rules of nature, there are rules of physics, there are rules of mathematics. All of these things are present uh, here. Now, if I just go to the next slide, so basically what we see here is that, if you can see this, I hope, right? Okay. Now, what you are able to see that, there are two different kind of, I just generated it from AI basically. So what you're trying to see on the left hand side is basically geometric patterns, and this is basically the Fibonacci, the golden ratios, right? The common things, like I said, I mean, the nature is the best mathematician. I mean, the basic maths, and we all deal with numbers every time. So if we see on the right hand side image, if we just a bit see it with proper attention, we see that the universe oldest secret, the Fibonacci sequence. And Fibonacci sequence is not what something not very like complex one. It is just you keep on adding the previous two numbers, you get the third number. But Fibonacci sequence occurs everywhere. It is appearing in the sunflower, pointing at the flower basically. If you see at the flower, it is occurring in the sunflower. The curve of the river, it follows a similar spiral path as it follows down the valley. The way the branches of the tree grows and divide, it echo the same sequence. There is a sequence involved, there is a pattern involved everywhere. So basically, the data here is the structure of the flower and path of the river. So it is not random. Nothing, in at least in our world, is random. In space, in Earth, in our daily lives, nothing is random. However, the data is so complex that we feel that it is random. It is highly organized. You know, this amazing mathematical pattern. It basically describes, how the things are working. Now, even if we see the geometrical pattern, you just look at the mountain peaks, you look at the triangles, the rocks, the trees, you would see a perpendicular structure arising from the ground. And then look at the sunlight, right? How you look at the sunlight, how it hits the ground. Those are perfect straight lines following the laws of light of propagation. The data here is the, the angle of the mountains, the straightness of the tree, and the direction of the light. These simple shapes and lines are at foundational data that define the physical world, basically, right? So what is our job? you know so basically, all secrets of this world is actually hidden in the data. It may be any data. It may be any kind of biological data. It may be the flowers data. It may be the crops data, the farming data, the nature data, the weather data, any data. The magic actually is already hidden in the data. So, like I said, the magic is not in the AI, the magic is in the data. AI is a lens to capture that. AI is actually a lens to capture that. Now, just one thing that uh, this is a different perspective of making you understand. This is actually how I see the data, how I have been seeing the data. This is my perspective. uh, if you pick up any book, they might have a different perspective. They might be very much mechanical, just starting from some formulas and everything. But then basically, when I think, see at all of these things, this is what I see. And I thought that, this is this perspective, and I have been like verifying all of this information is verified. Nothing that you can go ahead and check now. Obviously, chat gpt is always there. You can go to Gemini, chat gpt to check all of this information. So yeah, so there might be a chance that you might not find this information scribbled in some book or something like that, right? So this is, like I said, this is completely my perspective and a valid perspective, not a hypothetical hypothesis I'm presenting to you. I mean, obviously, I have been working on these fundamentals since almost now a decade, right? So magic is in the data. Like I said, AI is a lens to capture that. AI is a lens to capture that. So basically, now if you see, if you present the wrong data to the wrong lens, right, you will not end up with any good results. And this is what most of even the new startups fail to understand. A lot of reports you might have seen from McKinsey, etc., that a lot of AI projects are failing because what they are trying to do, they're trying to just force anything inside the LLM. They will just force anything inside the LLM, and they will expect that it should work. No, LLM is just a normal AI algorithm. Obviously, since it has been trained with lot of data, but it has limitations. It can do something, there is something it cannot do. There is some data it can understand, there is some data it cannot make out sense at all. So what we are here, basically, first and foremost thing, we will have to understand a lot of things, right? How nature encodes and decodes information. This is just an example format to make you understand basically how nature encodes and decodes the information. And basically, we are dealing with the real life problems. We are dealing with the problems of detecting the tumor. Even in tumor, Fibonacci sequence is formed, right? This we I have been like reading, so hence I know it. So obviously, even you know in many where in our body the Fibonacci sequence is formed. I mean, the Fibonacci is just one small thing, uh, but there are a lot of different patterns that humans do not know that we might discover in future. We might keep on discovering them. So what we have to do, we will have to understand the data. The moment you understand the data, the moment you start understanding the data, you have already cracked almost 60 to 70% of the problem, right? And then the other part of the problem is understanding is AI. We will apply this complex AI, to make understand that the hidden patterns that our human AI can never be able to see, right? All of those complex patterns and everything that human AI will never be able to see. So we will actually discover those things, right? So we'll actually discover all of those things. So basically, like I said, we will have to first uncover all the tools, all of the tools, how to understand the data, how to understand the data. That is the utmost important part, and there are various tools for doing that. Once we have the tool, right, then obviously we will also have to understand the nature of the algorithm that we are pushing our data into. Let's say for now, let's say if it is LLM, right? So we will go ahead and we will decode that what is present in this LLM, what is there in this LLM, what is there inside this large language model. is it really meant to read this data? Is it really meant to process this data, or there is some other algorithm that is meant to process this data, right? uh, okay, then the second part is obviously what we have done, finding the hidden patterns, that is hidden patterns, right? And third part is the forecasting. Third part is the forecasting. Forecasting is basically looking at the past data. You try to predict what can happen in the future, right? Looking at the past data, you try to predict that what is going to happen in the future. There are three, these are the essential three parts of real life application of AI. First and foremost thing, finding the hidden patterns. Once you are able to find the hidden patterns, and actually, like I have been speaking to my friends always, that this is where you should be always thinking around. This is how I have been thinking around for any idea, for anything. Uh, if you are able to find any very small hidden pattern in any kind of data, right, in weathers, in uh, human disease detection or anything, and basically you can actually have your complete product around it. And third is obviously the forecasting, which is actually the most toughest part. There is very little research on here, although when you google search, or when you go to any of your favorite llms and you type forecasting models, it will say that there are arima and all of those models, lstm and all of those models, algorithms are present, right? But obviously they're not very pitch perfect. It is still an art, and some people, some part of forecasting are able to do, and there is this part is still under active research. Now basically active research, obviously predicting the future is not an easy task. It is hell as anything, right? Okay, so going next is basically, all right, so we'll just like I said, we'll just see that how nature encodes and decodes this information. Right. How nature, first we'll just try to understand, one more perspective. I just want you to understand one perspective now. And why understanding that perspective is important, it is not just for fun. Basically, you will have to understand that what is the current state of AI, and what can happen next. That is, what is going to happen after 10 years, what is going to happen after 20 years, 30 years, 50 years from now. And if the nuclear war doesn't happen, right, if the nuclear war doesn't destroy us, then we keep on progressing. So basically, we have just scratched the surface of AI. We have just scratched the surface of AI. So basically, what is even, is there anything very advanced that can come? Yes, there are a lot of advanced things that can come. And for that, let's see some examples around us, right? Let's try to see some examples that are already present around us, right? So basically, if we just go and I just try to prepare this small video, I don't know, that is not playing, I guess. Never mind. Okay, let's start it. Right. So basically, if you see, there are three parts that I tried to basically cover here. The first is basically, if you see the Big Bang happening, the Big Bang happening. Now, I just want uh, to unlock your brain potentials. So basically, the Big Bang happening. The Big Bang happening. So what does it has to do with the AI and etc. Okay, I'll just come to that. The second is, the seed converting into a tree, right? The seed converting into a tree, right? Part two. And third part is basically that you already do, that is inside your brain. Your brain, it sees, processes information, and the finest part of AI that we are talking about, right? The finest AI. So basically, it is seeing, it stores some information, it processes information, and all of those things. It does a lot of things, right? Now, this is actually just the examples of what uh, natural AI or natural intelligence phenomena is. You know what? So basically, the concept here is that if you see anything, the nature has mastered one art that we humans have not been able to master till date, and that is basically compression of information. right? Compression of information. If you see anywhere, compression of information, in a seed, it has the complete detail. That small seed, right? It has complete information, right, of what the tree is going to be, what basically the fruits are going to be, what they're going to taste like. It has complete information. It is a complete packaged hard disk, that doesn't needs any power. It just needs some certain conditions. Now, obviously, if we see it from the mathematical point of view, right, there is some set of process of information using which this compressed information is going to evolve and get into a uncompressed information, right? And there is some from this uncompressed information, again from the fruit, again it goes into the compressed information that is in a seed format. That is one thing. Now, the second thing being that obviously, this is the example of a tree. Now, when obviously, the earth was big bang, some may argue that from big bang uh, the whole universe came into existence. Some may argue that the whole universe basically collapsed and a new one began, whatever you may consider. But yes, from singularity, that is singularity, from nothing, basically from nothing, even where the time does not exist, from nothing, everything got created. Everything got created. So there is some, and this information, the information that they store, the nature stores, is actually loss free. It does not makes much of the mistakes. In fact, 99.9% of accuracy. It stores the information with utmost accuracy, and lot of details it stores. There are a lot of details it keeps on storing, and then there are a lot of algorithms that keep on running, and this is where we see the word, right? And similarly, the other example being that, the other example of, in the plant, like I said, it already has. And how does it actually connect us? This is the plant, and how does it connect us? Now, basically, when you are actually chatting with your favorite large language model, what is actually happening? The process that is happening is basically all of the raw data. What they have done is all of the raw data they have compressed into, using a learning algorithm. They call it context vector. We will soon see what is a context vector. They have compressed it, all of that information, into context vector, right? So this is kind of one huge or set of matrices. Matrices in the sense 0 1, and these are not 0 1, that is basically these are 1.2, 1.3, 1.4. So basically a part of, calculus, that is. But don't worry, I will be explaining, like I said, I will be explaining it from zero, and these are very small, some simple concepts, right? So basically what it does is it has basically converted all of this information, the raw data, it has converted all of this information using a learning algorithm into this context vector, right? Okay, it got converted into context vector, and then using an algorithm, when you connect with it, it goes and checks and again decompresses that information, again decompresses, and you get your natural language. That is, it, you feel that, it is talking to you in some human language. And this is how this magic happens. But what is the difference between the previous one and this one? The compression that we are seeing as of now is not up to the mark, right? This is still a problem of research. This is not up to the mark. I mean, we are actually using calculus, specific calculus vectors, for basically making these compressions. Yes, it will work, but you see a lot of time people posting that how many are in the strawberry. See, they call it AI super AI and AGI, and it is not able to solve this small problem, or any kind of problem. It is not able to solve. Yes, obviously, because we are yet not there. The AGI that we keep on talking, we are yet not there. We might be there in next, maybe, I do not know, 10, 20, or 30 years, or 40 years. We might be there, and it is not happening from this plain simple calculus. It will need the quantum computing, and it will need some advanced topological, uh, you know, mathematics. Topological mathematics basically is a most advanced of form of mathematics that can replace calculus. Now again, I was actually planning to write a paper on this thing, but I unfortunately, due to all of these things, I could not get enough time. But yes, so uh, it can be topological or it can be something else, but mostly I guess the research is going on the topological vectors and topological mathematics, what we call that is the algebra of topology, and there are various other terms that I do not even know, right? So basically all of these things, calculus is, it is going to be there for a while, but yes, this whole concept that I'm trying to explain is going to be there for 30, 40, 50 years. It is not going anywhere. It has been there since 75 years. People have been using it, even in 1960s, 70s. If you go back and if you see, the plain uh, artificial intelligence algorithms, people have been using it for various purposes. They have made product out of it, they have sold it, and they vanished inside the pages of history. And this will keep on happening, uh, yes. So the summary here is that just LLM is not going to take us very far, but yes, what is going to take us far is, uh, you know, the if we learn how to crack all of that, uh, if we understand what is going beneath all of this AI, and then we learn how to decode our data, right? We learn, and that is again, like I said, it as easy, I'm saying it is not that easy, obviously, uh, but yes, all of those magic does occurs inside the data, and then with the algorithms, applying with the proper algorithm, we need to select the proper algorithm for whatever the task we need to do, and this is what the AI is all about. And then we will keep on discussing, what is there and what is not there. So next, I would like to, what is the current state of AI? Before that, mm, 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 okay. Before that, basically, let's try to understand, as I have already said that, what I have tried to tell you that all of this is happening and you will have to arrange all of the data. And let me just give a very small, plain, simple workflow, you know, that how does this AI actually learns, how this AI will learn, and this flow holds, this flow is valid for all of the future endeavors. Basically, it is not a rocket science. I mean, many of you might even know it. So let me just give me a second. Uh, right. Mm, mm, mm. Okay, let me know when you see the screen. All right. So basically, what is happening. The flow is always going to be the same. The flow is, first you collect the data. This is the flow that will always keep on happening. First and foremost thing, what you do is you will collect the data. Once you have collected the data, you will have to, right, data collection, again, this whole process, if you are doing it diligence, with due diligence, with proper seriousness, you can do wonders. This process rewards wonderfully. And when I say wonderfully, what have I built using these processes, using these simple processes? I have built products that have generated revenue in millions of dollars. So yes, right. So basically, it goes with data collection. It goes with, then we have, what we have to do is cleaning, right? Once we have collected the data, then basically it is the cleaning process. What is the cleaning process? Basically, we remove the noise from the data, right? Then is transformation of the data. Transformation means converting into a format that my algorithm understands, and it is different with different all different algorithms, right? And the problem here that we are seeing nowadays, everyone wants to dump all of their data in LLMs, and they want that it should work. It will, since it is supposed to understand numbers and text. Some of the part it might work, but it might not be working as you have expected. Any complex things, it might not be working, right? So basically, transformation has to be done as compared to problem. If it is a drug problem, we are discovering about the drugs, then obviously uh, there is a different set of algorithms that are involved in my GitHub. Although I never posted it on LinkedIn or in anywhere public, but I can share it. On GitHub, I had prepared one complete algorithm that is used for simple. It was a simple model for drug discovery, etc. Right? And then the next part is, obviously, after transformation, we will start exploring the data, and then modeling, that is giving our data to the model. Basically, then what we need to do is we need to give our data to the model, right? And after we have given the data to the model, next part is evaluation. Evaluation is checking that, is all of this flow making any sense or not? If this flow is making any sense or not, and if this flow is making sense, in evaluation, there are ways of automated evaluation, there are ways of manual evaluation, depending on how complex the problem is. And then basically, deployment means you open it to the public, and maybe you start charging and everything. And then basically the feedback mechanism, that okay, this part is working, because obviously any model, once it is released, it is not going to work on the day one. These models always work in the pyramid shape. In the sense, pyramid shape, when I say that, let me switch. Right. Okay. All right. So when I say that, it is going to work in the pyramid shape, so what does it mean? So always, nothing is going to, give you the output from day one. So then what you do is, so basically, first and foremost thing, we say that, okay, what it is going to do, there will be more amount of errors. And then gradually, with the release one, let's say you'll say that it has more amount of errors. And then gradually, with the release two, you say that it has less amount of errors. And then gradually it will keep on increasing, it will keep on decreasing, sorry, it will keep on decreasing. In the end, there's a pie on the top, and that means over the period of time, your AI has matured. Let's say it may take 1 year or 2 years or 3 years. Over the period of time, it will mature, right? And this is where the charm comes in. And this is where I have seen people, even after that, I've experienced myself that after 2 to 3 years of it has matured. There is just very little amount of effort that is required for it to uh, you know to work. That is it. It goes into autonomous stage. But yes, I mean, many of the people, what they see, that in release one this is happening, in release two this is happening, in release three they might decrease here, and then they basically lose any enthusiasm, because I mean, obviously people feel that maybe it is not going to work. But yeah, I mean, the magic happens when you keep on working it, when you keep on improving it, and in the end, it works very beautifully. All of these AI models, so they have their time span of maturing. You know, it takes some amount of time span for them to mature. Right. So basically, like already there that how AI finds the patterns. So basically, these are the steps that are required in finding the patterns. There are various ways, and even till date, I keep on finding all of the new ways of transforming the data. I keep on Yeah, I keep on all of the new ways of transforming the data. You know what? I keep on, there are, this is like I said, we are not in the mature state of mathematics as of now, although we have progressed a lot, but yes, I mean, like I said, I feel sometimes when I try to experiment some things, I hit a wall. And obviously, I am not that intelligent when I say that I can go ahead and invent any new uh, hypothesis on mathematics. Obviously, at least I alone cannot. But obviously, there are many bright minds working around the world, and uh, like small here and small improvements I can do on myself, I have been doing. But yes, obviously, some big breakthroughs, they require a lot of research. They require a dedicated research of many years, and then we see the results after years. Uh, so transformation, like I said, I still experiment a lot with transformation, and then we will see. Basically, today I will not go extremely deep into all of those things, right? Because it's just our first day. I will just keep it light, and the whole idea is that you learn it without realizing that you have been conquering something very difficult. This is what the whole idea is. So you should be able to learn the things with seeing them, with solving them. And obviously, if you experiment with me, then obviously, uh, I mean, there's a lot that we can do together. Now there is one more small example. I want a visualization that I want to show it to you. Again, I'll have to search it. Give me a second. Mm, mm, mm. Uh, mm, mm, mm. Okay, data life cycle, background, and okay, all right. So here I have it. Okay, all right. So basically, this is a small example, just a small example that now we have to talk about the real life things, obviously. So this is just a small data, that I have plotted. That is for the generation energy consumption, throughout the year. So for a small for a small location that I gathered, so basically, how much data is being, how much, sorry, uh, the energy is being consumed, throughout the year, through all of the 365 days. This is how the data is getting plotted. Although you might say that, this is a comparatively simpler problem to solve, but yes, obviously, this is a simpler problem to solve. And then this is a simple data. Then what we have transformed, we have tried to compress the information, not a very efficient way of doing it, right? This is a very inefficient way of doing it for your information, but yeah, I mean, just for the sake of display, what I've done is basically what we need to do, all of this data, we are just finding the average of it. So basically, when we find the average, basically, this specific kind of is showing me where almost my consumption can be. And then basically, based on that, what I can do, my model can basically learn. And not just that, this part, if you see the part that is actually hidden behind, basically a UI problem. So if you see this dotted line, this is able to forecast also. So there are various ways of forecasting. Now you might say, there are some dots that are present here. Yes, there are different models that can actually just focus on these specific dots. There are specific models that can just focus on anything else, But yes, AI is never about approximation. AI is never going to be about approximation. Your real life is all about probabilities. What can happen in the next hour? What can happen tomorrow, right? Tomorrow is, let's say, India Australia World Cup final, right? So what can happen tomorrow? You can actually, if you want to predict it, you will have to go through a lot of information. What kind of information? The weather information. If you should be having the proper pitch information. You should be having how does this player performs on this specific pitch and condition. How does this player performs on this specific bowler bowlings, right? So all of this complex relationship that gets into the picture, all of this complex relationship that gets into leads us to something very beautiful forecasting. And these forecasting, when done right, are very, very, very accurate. That doesn't mean that, I mean, you can forecast everything, but yes, I mean, theoretically, I definitely feel that you can forecast everything if you have the right algorithm, right? uh, like I said, as of now, we do not have all of the complex algorithms, including the LLMs. They have a lot of drawbacks. These LLMs have a lot of drawbacks and everything. And there will be some future algorithms that we will see, etc., and all of those things, right? So this is how basically, after, this is how we will be mostly working on. This is a very simple data. This is a 2D data. We will be working on 3D data, 4D data, 5D data, and n-dimensional data, right? Because calculus helps us to define multiple dimensions data. So many a times you might have been seeing in the sci-fi movies, that this is the fourth dimension thing, this is the nth dimension thing. This is the time we will actually be working on those multiple dimensions, right? And like I said, that a lot of data doesn't fits into the calculus. What does it means? It means that, let me switch back. What does it means, right? It means that basically, okay, you can see, right. So it means that, uh, we have the data modulation problem. Data modulation in the sense modeling the data, right? We are still trying to understand a lot of data, a lot of complex data. If you see, this to 24-25, we have made very good progress in predicting the weather. But before that, even now, if you see, sometimes with the weather prediction goes horribly wrong, because the data is at most complex. The data is having so many complex interconnected parameters, so many complex, and this is where the complexity of data is, so many complex interconnected parameters, right? Interconnected parameter. This is parameter 1, this is parameter 2, this is parameter 3, and they're interconnected and they influence each other, right? They influence each other. They influence, all of these parameters are going to influence each other, and then this influence should actually produce some result. All of this influence should produce some result. Now, we don't have that perfect mechanism as of now, right? And second, like I said, that all of this modeling data, weather is one example. Even the second example that I gave you, although it is easier to talk, that if you want to predict that what can happen exactly, the probability, what player will be playing, then if you have the proper health information of those players, the form information, and basically what kind of ball they can play, what kind of ball they cannot play. Even in the cricket nowadays, it's everything maths. They are very carefully observing that, okay, this player is able to play to this line and length to this speed, and he cannot hit this specific area, then we will concentrate on those areas only, right? There's already an analyst sitting with all of these teams, right? So basically, yeah, what I was talking about, the forecasting thing, your forecasting depends on a lot of parameters, and those for forecasting, obviously, our calculus is a bit weak here. Calculus is a bit weak here. So there are other branches of mathematics that are already that we are already working on. You know, there's a very interesting story, and you can go ahead and verify that. There is a scientist who actually I forgot the name. Actually, I wasn't prepared for this, but there is a scientist. He talks on a specific term called as AI consciousness. AI consciousness. He talks on this AI consciousness, and what he tells that he got a call from the future AI. That is, in the future AI, they are able to develop AI, that is, and they develop that AI, with some quantum computing, and they're able to basically manipulate the time parameter. I mean, again, I don't take uh, any credibility of this story. I mean, this is some by some scientist who still lives with us today, and he's a very renowned scientist. And these are his statements. I mean, God knows what it is true or not, right? Sorry, anyone? Yeah, sure. So, all right. So basically, what I was trying to tell that the calculus is still evolving. In after calculus, where we might land. So there was a very beautiful animation that I was showcasing when I started. That was basically the topological animation, and I'll just reshare it. The topological animation, and if you see, this is what is this? This is an interconnected mesh. This, you see these small dots, relationships, and everything. Now, this might seem like something very beautiful, but this is actually a mesh. This is a topology, a new kind of, and not a new. Obviously, this subject has been quite uh, long before. But again, I mean, this is just a fun fact. We will not be studying this subject at all. This is just something, what I feel that in future this can be something big. uh, uh, but yeah, I mean, the process is going to be same. It is just, we need something better, or maybe they might be able to evolve a new branch of calculus, or they might already be talking about it. I might not have read any papers around it. So basically, the whole point being, we need more data, or we need more complex methods which can understand the relationships between the edges, between the nodes, and how do they influence each other. This is one kind of data. This is not any animation. This is a data. This is although this is 3D animation, but this is a 3D data that I have tried to plot using topological thing. I'm not a expert in any of these topological things or anything, right? I'm just just try to demonstrate all of these things. These things excite me also a lot, and I keep on reading about this. So just thought I'll share about it, right? So okay, coming back to our AI topic. Coming back to our AI topic, so where AI is today, like obviously the AI today that we are using is all about, it's all about calculus, it's all about this linear algebra, it's all about probability, you know, uh, all of the things that we actually deal with our daily life, although you might not be creating equations around it in the daily life. But yes, we don't need to create equations around it even when we are going ahead, right? So these are some simple concepts that we'll be using, and I will be demonstrating all of those things just like the playgrounds I have demonstrated to you. So do not worry about it. This time you will see a different perspective of mathematics just related to your real life. Like I have already been saying, you already use a lot of mathematics concepts in your daily life. You just don't realize it, right? Uh, so this time I'll be making you visualize all of those things before you, right? And then the current state of AI, obviously, we are not in that advanced stage. We are not in that advanced stage that, yeah, obviously, what all the fake marketing you see around, that AI should be able to do this, AI should be able to do that, all of that specific information, there is a lot of work that needs to be done. We are not near AGI. However, what we are near, we will discover that also. One definition that I gave you is that maths, all of the data, magic is in the data. Magic is not, magic is in data, right? Magic is in data. And, the proper tool and skills. Now, basically, we will soon, this is a practice skill that you will have to develop. Some of the, obviously, we'll be doing that right here, but I will be including some really complex examples also. Let me see that what complex example I can see. And what I always feel, what I always feel that if in order to get success, you should stick to one data for a longer period of time. Let's say any data you are trying to conquer, there is any data you are trying to conquer, because understanding the edges, relationships, there are some relationships, there are so many permutation combinations of a data that some relationships, uh, humans, some human might know, and there are some relationships other human might know, right? So basically, when you spend huge amount of data, huge amount of time with specific kind of data, it can be a supply chain data, if you can be a supply chain specialist, or it can be something related to weather. uh, Earlier to that, I was actually I worked a lot on natural language processing, that is, the text data. I have worked a lot with text data, almost, I guess, 7 to 8 years I've spent with text data. Then basically, it can be any kind of data, and not just that, I mean, it can be specific kind of financial data, any finance data, banking data, anything it can be. And when you regularly see the visualizations, when you see those graphs again and again, when you will start discovering the patterns that nobody else is able to see. That research really rewards you. You'll start seeing those patterns, and then you can automate those using AI. Obviously, AI is an algorithm. Again, I give you one more definition of AI. What is AI? AI is a huge, it is a huge statistical, statistical mapper. Mapper. It is a mapper. As of now, it is a mapping engine for, if we leave aside the forecasting, even forecasting is a kind of mapping only. If we leave aside forecasting, it is a huge statistical mapper. What do you mean by that? What does this statement mean? The statement simply means that what it is trying to do, now you will understand that why your LLMs are not able to answer few things. So what it has done, let's say this is, let's say, sample one. Sample one can, now you sample this, can sample here, this is data. This can be image data, this can be text data, it can be a paragraph, it can be a medical report or anything. This is sample one, and there is already an output. There is already an output that, okay, this sample one should do this. It can be an action, it can be anything. Let's say in chat GPT example, so sample one, its answer is answer one. Let's say sample two, its already answer is answer two. This is the kind of mapping it has internally, and it doesn't mean that there is an Excel sheet around it. Like I said, there's a complex context vector sitting there, and this is a simplified format of telling you what is happening inside, right? Obviously, there is huge complex, like, calculus, vectors, basically vector operations going inside, right? So sample one, sample two, so all of these mappings, it keeps on happening. All of these mappings, these, and then when you ask about sample one, it goes and it actually searches that it matches at most which one. Okay, it says that, okay, I match to sample one. Okay, I the query that user has put sample one, and I should answer is answer one. Do you see? It is a mechanical process. Although done in a very scientific manner, it is a mechanical searching process. What feels to us like a magic? What feels to us like a magic? And magic happens because this is just three things. It has billions of such data points. Actually, even billions, I guess it has trillions of data points. Trillions of data points, you know and those trillions of data points, sometimes it makes mistakes. Sometimes it considers that, okay, this sample one should be mapped to some answer two, and you say that, oh, this is not working fine at all. You know, this is what I expect. Sometimes you feel that some uh, 2 months back when you asked the same query, it gave you one answer, right? And after 2 months, you asked the same query, it gave you another answer. Obviously, it was again trained. It was trained again, right? So basically, like I said, that it is a huge statistical mapper. It maps your data to from your data points to your output. This is what is called as the training process. This is what is called as the training process, right? This is one very huge part of AI that we have till date. That doesn't mean this is the only part of AI that we have, and hence, what the whole idea is that, I'm not just here to uh, tell you about the beauty of the LLMs and etc. and all of those, right? Okay, the whole idea is that you take up any problem, you should be able to solve that problem. You should be able to solve that problem. So there are various ways you can solve them. If it is a huge tabular data, then obviously it is not LLM that you should be using, right? There's the different random forest or advanced random forest you should be using. If there is something else, then obviously you should be building your own decision tree. Sorry, the random forest is decision tree only, right? If there is something else, you can use Bayes theorem or anything like that. So there are various ways. If this is something, then you can use LLMs, and then we'll see that how we can tweak LLMs also. I mean, I will cover even more comprehensive example that I covered from previous session, previous batch. That is how we can tweak the LLMs. If we want to fine tune or train our own LLMs, how we can do that. You can train our own LLMs. You can fine tune them. You can train from scratch and do all of those things. So this is what this course is going to be about. You know, I just wanted to brief in the first session that what this course is going to be about, and from tomorrow's session, first and foremost thing, like what we want is that, first and foremost thing, like I said, AI is 70% about data. Always choose a problem that has, if you want to build a startup, always make sure you have a lot of data around that problem. If you want to build an AI startup around it, or if you want to build an AI service around it, you can have a small website of yours that can just sell some service, right? I mean, it doesn't has to be a full-fledged startup that is going to squeeze money from any investor or anything. You can just build a small service around it, and you can just sell that small service from your website, right? So yes, but it should have that right data. It should have huge amount of data. Once you have data, then obviously it doesn't mean the problem gets solved. But yes, you can spend few months on it, or maybe spend few weeks, few months, depending on how complex what you are trying to solve, right? How much complex problem you're trying to solve. You can then basically visualize them. You can find patterns. You can apply all the algorithms, and finally you can have a solution around it. So first and foremost thing, what we'll be studying here is we'll be studying various ways how we can analyze this data. Like I said, all of that, it is not going to be a theory based. We will understand with the problems. Like first we will understand with some problem, right? We'll have a case study one, and how do we solve that? Then we have a case study two, how do we solve that? In the end, the whole idea is going towards basically deep learning. Deep learning is basically how neural networks work, and deep learning has a part wherein transformer, right? It has a part called transformer on which LLMs are built, right? On which LLMs are built, right? So this is how we will take it forward. I will keep the first day short itself, not extending too much, not boring everyone too much, right? If there is any doubt, kindly you can pitch it to me, or else we can actually. Is this time actually good? 12 to 1 or 12 to 1:30 maybe?
Yeah, at least this works for me here.
Yeah, right.
Yeah.
So yeah,
Yeah,
all
even
right.
if you do it before lunch, right? At lunch it'll be
All,
more heavy.
yeah, yeah, Dhaval. You have anything?
Yeah, it works. It works.
Okay, cool. Then yeah, I mean we can catch up at the same time, and tomorrow slowly with the right visualizations. My idea is that we start discovering all of those topics, and see. The other point, you will have to at least practice with me. It doesn't work that you just listen it. I am trying my best so that I don't bore you out, but you will have to go back and at least, I will be giving all of the code that I write here. I'll be writing everything before you. You will have to, at least if you don't rewrite it, at least try to run it. At least try to run those things, right? Only then it makes sense. Only then you will start enjoying the things, right? All right, guys, have a nice Saturday ahead. Let's catch up tomorrow.
Thanks,
Bye.
Anand.
Thank you. Bye.
Thank you,
Thanks.
Anand.
Thanks.
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 Bye, Anand.
Bye. Bye.